Hey, Chapter 4, Factoring with Perfect Squares. If you watch some of the other videos, this is going to look pretty darn familiar. If you haven't watched the greatest common factor video yet, I will warn you. So for factoring, no matter what, you're always supposed to look for greatest common factor first. But if you're not sure what that is, please watch the GCF video. All right, so I have a bunch of trinomials here. And essentially, we learned that we were just undoing them into something times something. So just basically we're making a FOIL problem, going backwards. So we want to go the same way as we were with the other ones. And I start with the first thing in the problem. I put something times something that will give me the first thing in the parentheses that gives me that a squared. So a times a is a squared. And I drop down here to the end, and I want to put something on the end, times something on the end that's going to give me 36, 6 times 6. Now again, there are other ways to get 36 besides 6 times 6. 4 times 9 would work. 2 times 18 is 36. And for that matter, 1 times 36 is. So why does this guy work? Well, let me get some signs in here first. That entire problem is plus signs, so it makes sense that the entire answer would be plus signs. Now, if you get this far and if you don't take the time to check them, you are insane. This guarantees you being right. If I multiply the outside guy and the inside guy, it's going to tell me if I'm right. So I multiply the outside guys, I get 6 times a, which is 6a. I got another 6a when I multiply the inside two guys together. They're both positives. And if I add them up, I get 12a. Well, what's up here dead in the middle of the problem? 12a. So that guarantees that I'm right. So if I tried 4 and 9, not going to work. 2 and 18, same thing. 1 and 36, same thing. Now, if you knew going in that you were doing squares, well, a square is a number times itself. But if you get all these factoring problems mixed together, you might have to go through that little process and double check it. So it just never hurts to double check. So now here's the catch with math, right? This a plus 6 and a plus 6 is right, but math is always supposed to be in simplest form. And a better way to write something times itself would be to write it squared. Because a plus 6 squared means a plus 6 times a plus 6. So best answer right there. Okay, number 2. Basically going backwards on a FOIL problem. Start with the guy up front. What times what is m squared? M times n. Go to the guy in the end. What times what is 4n squared? Well, 2 times 2 will get me the 4. And n times n will get me the n squared. And that's it. That's covered. Okay, now, the whole problem is not plus signs, so I'm not using all plus signs. But I still have to get this positive 4. So what's another way we could use signs to get a positive answer? How about a negative times a negative? Okay, now assuming this answer is right, I'm going to go ahead and skip down to the bottom. And this only applies if your parentheses are matching. The best way to write the final answer for that guy is m minus 2n squared. But I'm going to take the time to check it anyway. If I multiply those two guys together, I get negative 2mn. Multiply those two guys together, I get negative 2mn. Well, what do those add up to? They add up to that guy right there in the middle, so that guarantees I'm right. So again, if you don't take the time to check these, I'm telling you, you're crazy, because you know how often in math you absolutely 100% sure know that you're right. And this is that chance to do that. Okay, just because this 9's here, don't let it throw you. I'm still undoing a FOIL problem. So I'm still going a binomial times a binomial. So let's start here. What times what is 9x squared? 3 times 3 would cover the 9. X times x would cover the x squared. Now again, 9 times 1 would also be 9x squared, but if you knew you're doing perfect squares, then we know we got to use the same number. So 2 times 8, no, that's not a perfect square. 1 times 16, no, that's not a perfect square. But 4 times itself is a perfect square. So if you're doing a perfect square problem, I will tell you the signs have to match. But again, you might not know that going in, so these could be all mixed together. So it never hurts to just take the time to do this. I have a positive 16 on the end, and I just wrote a 4 and a 4. So how do I get a positive 16? I could go positive times positive, but the whole problem isn't plus signs. But I could also go negative times a negative, and that would give me a positive 16 if I times together. Take the time to check them. And you don't have to write them down. You can just do it mentally. But since I'm doing notes here, I'm going to write it down. A 3x times a negative 4 would be that. A negative 4 times a 3x would be that. And if I combine those two guys, do I get this 20, negative 24? And the answer is yes. So you've just guaranteed yourself being correct. But again, math is simplest form. If the parentheses don't match, you wouldn't bother doing this. But the parentheses do match. Now I want to write him with a squared. 3x minus 4 squared, final answer. All right, folks, that's how you go about doing perfect squares. Thanks for watching.